Hey guys, Mr. McKinney here, just going through one of the more challenging problems from Math Excel this unit. First of all, if you didn't get this problem on your own, don't freak out too much. This is more challenging than what you'll see on our exam, but it could show up on the AP exam. And this is the type of question that if you're getting this right, you're on track to get a 5. All right, so we want to minimize the total travel time in this situation. So I'm going to give you a couple hints and then go through the whole thing. So first of all, we need to know the equation that distance is equal to rate multiplied by time. That's a common equation. The distance traveled is equal to the rate multiplied by the time. In this problem, we're going to want to solve for t. So any given time is the distance divided by the rate. So if we want to minimize the total travel time, we need an equation for total travel time. So I'm just going to call that time, let's just call it time total, is going to be the time rowing plus the time walking. So for each of these, we're going to do d over r. So it's going to be the distance rowing, divided by the rate rowing plus the distance walking divided by the rate walking is going to be the time that we're going to be looking at. Now we can find these distances from the picture, and then the rates are given to us. We're going to take the derivative, set it equal to 0, and then solve for our variable. And I'll walk through it in a second. For the second one, we want to minimize the speed at which she must row so that the quickest way to the restaurant is to row directly. So this is a pretty challenging problem. Basically, you're going to use the same equation from up here, except your rowing rate will become a variable. And then when you get the derivative, you know that the derivative when you're doing a straight line distance is going to be 0. So a derivative of one of the endpoints, and I'll get into it when we get into the problem. The derivative at one of the endpoints is 0 because and we'll get into why that's the case in a second. But you would say that the derivative at the endpoint is 0 and then solve for the rate, which is now a variable. So those are the hints, and now we're going to walk through it all the way. All right, so in our picture up here, we're trying to minimize the total travel time, but the question asks, at what point should we land? So this point, and the question asks how many miles from the restaurant. So I'm going to make that the variable. How many miles from the restaurant is going to be the variable, which would mean that this distance is going to be 11 minus my variable. And it would mean that this distance, using the Pythagorean theorem, would be the square root of 3 squared, which is 9, plus this side squared, which is 11, minus x squared. All right, I'm going to hit pause real quick because I'm going to go watch the International Space Station fly by. All right, I'm back. That was pretty cool. And I took a short video, so I'll try to make a link for that if I get a chance. All right, so we want to minimize the total travel time. So there's going to be time rowing, and then there's going to be time walking. Like the path we're going to take is from here and then over here. So the total time is going to be equal to those two times added together. So the time rowing plus the time walking. Now we're going to use the equation distance equals rate times time and solve for time. So for each of these, the time rowing can be the distance rowing divided by the rate rowing. And the time walking can be the distance walking divided by the rate walking. So our total time, which I'm just going to call t, is equal to this equation. The distance rowing we can find as this hypotenuse of this triangle. So the square root of 9 plus 11 minus x squared divided by the rate rowing, that's here, is 2. And then the distance walking was x, because that's what that question is asking for, basically, divided by the rate walking, which was 3. So anytime we want to maximize, or in this case minimize something, we're going to find the derivative and then set it equal to 0 and find when it goes from negative to positive. So I'm going to rewrite this equation as 9 plus 11 minus x squared to the 1/2. So to move this 2 out front, that's a 1/2. And then the power rule with the chain rule. So 1/2 times 9 plus 11 minus x squared. Now it's to the negative 1/2 power times derivative of the inside. The constant goes away. So 2 times 11 minus x times the derivative of x is negative 1. So that's the derivative of that part. And then this is much easier. The derivative of x divided by 3 is 1/3. So let's simplify this a little bit. We can cancel out this 2 and this 2. So t prime equals 1. Well, we're actually going to have this 11 minus x and a negative 1 on top. So negative 1 times 11 minus x divided by this square root, moves down to the bottom, 9 plus 11 minus x squared. And then, let's see, we've got this, plus 1/3. We want to know when that's equal to 0. So I'm going to add this term over to the other side. I'm going to switch colors. So when I add this term to the other side, we'd have 1/3 equals 11 minus x over the square root of 9 plus 11 minus x squared. It's not negative anymore because I added it over to the other side. Can cross multiply, so 3 times 11 minus x is the square root. Sorry, I lost this factor of 2. This 2 should be there, and here, and here. All right, so I need to get rid of the square root. So I'm going to square both sides. So 9 times 11 minus x squared, 4 times 9 plus 11 minus x squared. And if we were on the AP exam, on the calculator portion, we would definitely be solving this. We would have just up here solved it using a calculator. But MathXL needs an exact value, so we got to keep going by hand. So 9 times 121 minus 22x plus x squared equals 4 times 9 would be 36, and then 4 times, if I multiply that out, it's the same thing here, 121 minus 22x plus x squared. So multiply that out, we're going to get 1089 minus 198x plus 9x squared. And then if I multiply out over here, you're going to have 36 plus 484 minus 88x plus 4x squared. I'm going to move all this over to the left side to make it equal to 0. 5x squared, 9 minus the 4. Same idea for everything else. And I'll end up with 110x plus 569. Use the quadratic formula here, and you would get two solutions. X would either be 110 plus or minus the square root of 720 divided by 10. Now, if we use the positive version here, it's going to be more than 11, which doesn't make sense. So we have to use the negative version. So x would be equal to the 110 minus root 720 over 10. And then you would set up your table. I'm running out of room, so I'm not going to show that part. But x and the t prime, 0, that value would go in there. And if you plug in values on either side, you'll see that it goes from negative to positive. So that's the answer to the first part. And the second part requires a similar equation, but a different type of thinking. So on this one, we're trying to minimize the speed at which you would row if this was going to be the fastest way. So if this minimized the time. So in a sense, we're still trying to minimize the time, but we have to figure out what the speed is in order to minimize it. So we kind of have two variables, and then we're going to get rid of one of them, and I'll talk about how in a second. So we're going to use everything the same as before. The distance that's walking is x. This distance over here is 11 minus x. And so then the distance that she's traveling is the square root of 9 plus 11 minus x squared. Now, we're going to use almost the same equation for our time, but instead of having the rate walking as 2 in the previous example, we don't know what it is. So the equation is the same as before, except instead of dividing by 2, it's still RR. So square root of 9 plus 11 minus x squared plus x divided by 3. So we start out exactly the same way. Take the derivative exactly the same way. The difference will be that instead of having a 2 on the bottom, when we took the derivative here, that 2 came from the rate, so that 2 is actually going to just be an r. And instead of using RR, there's only one r for this part, so I'm just going to call it r. So once I take the derivative, it's the same derivative as before. I'm not going to show all that work again. So negative 11 minus x divided by r times the square root of 9 plus 11 minus x squared. Square root of this is still 1/3. Now the key piece here is that we know that t prime at x equals 0 is a minimum. Or sorry, not t prime equals 0 because at x equals 0. So when the walking distance is 0, the derivative is equal to 0 because the total time is at a minimum. Because we know that the total time is at a minimum when when the walking distance is 0. So this is the key piece that we need to be thinking about. So again, t prime is equal to 0 when x is equal to 0 because we know that the total time is at a minimum at that time. So we're going to say when x is 0, so negative 11 over r times the square root of 9 plus 11 squared plus 1/3, it's equal to 0. The derivative is equal to 0. So 1/3 equals 11 over r times the square root of 9 plus 11 squared. So we would have 1/3 equals 11 over r root 130, cross multiply, 33 equals r root 130, and then divide by root 130. So r equals 33 over the square root of 130. So that is the rate that would minimize, that's the minimum rate that she would have to go in order for the distance to be 0 that she's walking. So, hope that helped.